Hi everyone, welcome back to my channel, and today class I am going to discuss the properties of Laplace transforms. In the previous class we have discussed the Laplace transforms, introduction of Laplace transforms. What is Laplace transforms, what is the importance of Laplace transforms, and how to calculate the Laplace transforms of different input signals. So all we have calculated in the previous class. Now in this class, so what are the properties of Laplace transforms? So what is the meaning? What is the use of properties of Laplace transforms? So to calculate the time domain functions, definitely we need these properties. Because of time domain functions, it's a very complex functions. They are in complexity. Okay, now to calculate complex equations, we need that properties of Laplace transforms. So in this class, so I will not discuss the proofs of the properties. I will discuss only the property and one example. Because of we will discuss all properties in the signals and systems subject. Because of this is a Laplace transforms, which is we will discuss in detail in the signals and systems. Okay, so in this class, so I'm going to discuss the properties of Laplace transforms. Okay, briefly. Okay, the first property is linearity property. The first property, so linearity. Okay, a linearity is the function f1 of t in time domain which has Laplace transform f1 of s, and the function f of t in time domain which has Laplace transform f2 of s. So then according to the linearity property, so if you multiply any constant with the f1 of t and plus and b another constant with f2 of t is equal to a into f1 of s plus b into f2 of s. This is a statement of the linearity. Actually, linearity property is the combination of homogeneity and superposition principles. What is homogeneity? Homogeneity means here f1 of t. So if you multiply any constant with function, that is, let us suppose a function a, if you multiply, this is a is a constant. If you multiply a constant with function f1 of t, so after transforming the function t to s domain, the same constant multiplied with the s domain function. This is a into f1 of s. Similarly for b, I multiplied, so b is a constant with the f2 of t. So after transforming the function t to s domain, the same constant multiplied with the s domain function, that is a b into f2 of s. Okay, and so a and the f1 of t becomes f1 of s, f2 of t becomes f2, because of f1 of t has the transfer function f1 of s and f2 of t has the transfer function f2 of s. Okay, the same. So here I can multiply a constant a with f1 of t. The same constant I can multiply with f1 of s. That is homogeneity. What is superposition? So after multiplication of constant with function, then I can add it. That is, I can add these two functions time domain, the same functions which are transfer functions, I can add after conversions. That is a into f1 of s plus b into f2 of s. This is a linearity property. So I can take simple example here. So example here. So find Laplace transform of the function u of t plus 2 into e power minus 2t plus 3 into sine of 3t. Let us suppose this is the function is f of t is equal to u of t plus t into e power minus 2t plus 3 sine 3t. Okay, na? Just I can apply here. I can apply Laplace transforms. Laplace transform of f of t is equal to Laplace transform of u of t plus 2 into e power minus 2t plus 3 into sine of 3t. So don't use the formula to calculate the S domain functions. Already we have discussed in the previous class to how to get the Laplace transform of u of t. You know that Laplace transform of u of t is 1 by s. Am I correct or not? Yes. So that is, I can apply Laplace transform to individual functions. So Laplace transform of u of t plus, and Laplace transform of 2 into e power minus 2t plus, and Laplace transform of 3 into sine of 3t. Okay, we know that here Laplace transform of u of t is, that is 1 by s plus, and Laplace 2 is constant, I can write outside here, Laplace transform of e power minus 2t, that is 1 upon s plus a. So e power minus 8t, that is Laplace transform of e power minus 80 is equal to 1 upon s plus a. In the place of a 2 is there, then 1 by s plus a, that is s plus 2, then plus 3 is a constant, I can write outside here, then sine 3t, that is Laplace transform of sine of omega t is equal to, the formula is omega by s square plus omega square. In the place omega, 3 is there, therefore omega by s square, omega means 3 by s square plus omega square, 3 square. This is the Laplace transform. So here we can use the linearity property. So we can add all this here, so constant 2 and function and 3. So this is called as a linearity property. So that's why Laplace transforms are very important in control systems. Okay, the next property is here time scaling property. Okay, next property is here time scaling property. Next, second property, time scaling. What is time scaling? Let us suppose f of t in time domain which has transfer function, that is f of s. If I multiply the any constant with augmented function, so if I multiply any constant with augmented function of this function, that is called as a time scaling function, that is f of t. F of t I can multiply it with the a into t, so I can multiply this t function here, okay, with some constant a. So that is, it has some transfer function, that is 1 by mod a f of s by a. This is a time scaling function property. Okay, to understand this I can take simple example. So find Laplace transform of f of 2t if f of t is equal to 1 by s plus 1. Okay, you know that according to the formula here, Laplace transform of 2t is equal to, so 1 by mod a, in the place of a we have 2, so mod 2 and f of s by 2, in the place of a 2 is s by 2, then 1 by 2 mod a mod 2, so 1 by 2 is equal to f of s by 2. What is the function here? F of t is a function. Okay, and f of t is a function. F of t is equal to 1 by s plus 1. Sorry, this is a f of s is equal to s plus 1. Okay, in the place of s I can substitute s by 2, then 1 by s by 2 plus 1. Simplify here, 1 by 2 into LCM is here 2, so 2 by 2. So I can write upside 1 by 2 into 2 by s plus 2, 2 to get cancelled, 1 by s plus 2. This is a Laplace transform of f of 2t. So this is a important property of Laplace transform to calculate any differential equations. Okay, thank you and thank you very much. We will discuss remaining properties in the next class. Thank you and thank you.